Hey everybody, in this next video lesson, I'm going to talk about all the different ways that we can determine the pH in a solution. We've learned what pH is and we've learned about how to calculate pH, but if you're in a lab setting, how do you determine what the pH is of a solution? Well, I'm going to take you through a number of different ways that we do this, starting from the least precise and ending up with the most precise. Now the first one we talk about is called litmus paper. Now litmus paper comes in two types. It's red litmus paper or blue litmus paper. Red litmus paper turns blue in a base but stays red in an acid. Think red, acid, blue base. So red paper stays red in an acid, turns blue in a base. Blue paper turns red in an acid and stays blue in a base. So what if you're trying to figure out if it's neutral or not? Well, you have to use both red and blue litmus paper to test a solution. Because let's just say you have an acid and you're using red litmus paper and it stays red. Now it could be neutral or it could be acidic. But then you use the blue litmus paper and you notice that it stays blue, meaning it's neutral. So you really have to use both of them in conjunction with each other in order to determine if it's not neutral. Now neutral is a very specific situation and it's a very narrow range of neutrality. So chances are it's either going to be red or blue. And you have a pretty good idea if it's an acid or a base using just one litmus paper, but use two litmus papers just to be sure. Usually litmus paper is used only if you want to ensure something is acidic or something is basic, not really in the cases of trying to find out if it's neutral or not. Now, along the same lines as litmus paper, we have pH paper, and it's a little bit more precise than litmus paper, where litmus paper just tells you if it's pH below 7 or pH above 7. This is specifically chemically treated paper that changes a different color or different shade of a color depending on how acidic or basic something is. And it's a little bit more precise than litmus paper, but not by much. Like, for example, it's very difficult to tell the difference between a pH of 2 and a pH of 3. And so when you dip the little strip of paper in and it changes the color and you compare it with the color on the side of the container and you're like, it looks like a 2, maybe a 3. Well, that's really the best you can do. And what if you're colorblind? Maybe you have color blindness and you can't tell the difference between your shades of red or your shades of yellow and shades of green. So this is not perfect, but it is something that we've used and developed over time. And it typically will get you to the nearest whole number, but you can't get like fractions of a pH. You can't get like the 2.5 or the 2.6 or 2.7 or something like that. They're just not precise enough. But they can get you to a relatively accurate pH depending on a whole number. Now the next indicator of a pH is what it is, an indicator of pH. pH indicator is a dye that you add to a solution that changes color depending on a specific pH. Let's say you have a beaker of clear substance and you don't know if it's an acid or a base, and you drip in some of this methyl red. Methyl red stays red in pHs up to 4, and then is a little bit orange in the 5 to 6 range, and then is yellow once you get into the basic range, 7, 8, 9, 10, 11, 12. So if you drop it in and it stays yellow, you're like, oh, it's a base. Or if you drop it in and it stays red, you're like, oh, it's an acid. But what's cool is that the color can change depending on how much base you add to your acid. So let's say you have methyl red inside an acid, and it starts as red, and then you start adding base a little bit at a time, and the pH is going to get slightly higher and slightly higher and slightly higher, and eventually you add a little bit more base and it's going to turn slightly orange, and all of a sudden you're like, oh, it must be around 5 or 6, and then you add a little bit more base and it's a little bit more yellow and more yellow and more yellow, and so the color changes with how much base you add. Or maybe you have base and you're adding acid, so it lowers the pH. pH indicators are really useful, and there's many different indicators depending on what pH you want to test in. So let's say, for example, you want to use bromophenol blue, which is yellow in an acid, acids 1s, 2, and 3 at pH, but in the 4 or 5 range, it's green, and then once you get up into the blue range, you got 8, 9, 10, so on and so forth. The two most common that we use in class are phenolphthalein, which is really cool because it stays clear in an acid and then turns pink as soon as it reaches about pH of 8. So this light pink color will start to develop when you at a pH of 8 or 9. So you're adding base to your acid and it's staying clear and it's staying clear and it's staying clear. And then you add a few more drops of base and all of a sudden the pink color shows up and it stays, and you know you're at about pH of 8. This one is going to be used most often. It is by far the most common pH indicator that we use. Another one that is particularly useful is bromothymol blue because it changes color at or about a 7 pH. If you notice, most of these don't change color in the 7 pH range, which is the neutral range, because you kind of want to know when you go from an acid to a base or from a base to an acid. You want to know at that point when that's happening. And bromothymol blue is pretty much the only one at which the color changes happening at or about 7 pH. And so this one's particularly useful for understanding or knowing when you've reached specifically the neutral pHs. Now, the last one we're going to talk about is pH meter. It's more precise. In fact, it's the most precise. It can read pHs 2 past the decimal, sometimes even 3 past the decimal. And you might be saying, well, if it's the most precise, then why don't we use them? Well, that precision comes at a price, literally. They cost a lot of money. Now, fortunately for you, we've collected enough pH probes, which is also known as a pH meter, pH probe. We've collected enough pH meters over the years in order to have a fair amount of them to use for class, but they are electronic, so they run out of batteries. They need to be recharged. They're particularly finicky. You have to store them in a particular solution, otherwise they kind of get corroded and gross and unusable. And so pH meters are great, but they're a bit finicky, so hard to use. Also, they're least precise around pHs of 7, because the way they work is they're measuring how much ions are in solution by running a little bit of electricity through the solution. And when the solution is neutral at pH of 7, that is when there is the least amount of ions in solution. And so it's measuring the pH at about 7. It's the least precise. So they're best with extremely low pHs or extremely high pHs, but not all that sensitive around 6, 7, and 8 pH. So that is one limitation to the pH meter. Well, that takes care of this video lesson on different ways that you can determine the pH of a solution. Thanks for watching.